Thank you. Um, Hi everyone, I'm Vicente. I'm from Barcelona, Spain, part of the Barusotal team for the last 5 years. And today I want to show you what is or what has been our journey in trying to use LLMs for malware analysis, which in case that you are in a rush, we don't fix it yet. But if you want to stay here, I will show you the different problems that we found in our journey, the different decisions that we made. Hopefully this is useful for the whole community to better understand what kind of things can be done with the current technology, at least according to our experimentation and experience. In case that someone is not familiar with VirusTotal, this is a service that we started 20 years ago. And basically, we had the idea, all right, let's provide the capability for people to upload any type of file into our website, and we will scan this with all the different antiviruses, and then we will let you know where is the outcome. With time, this evolved. Basically, we have today probably the biggest malware database in the planet. And we provide the capability to search by any criteria. We run all the malware, all the files through many different tools, many different AVs, sandboxes, and basically it's used by basically the whole industry to do hunting and to find trends in terms of malware and understand a little bit better how things change and evolve. Having said that, let's go into the topic, which is using LLMs for malware analysis. Basically, this is something that we started working on a couple of years ago. And the whole idea was, well, LLMs look like great in order to create code. How are they in order to read code and let us know what the code is doing? In many cases, malware is very easy to read. Let's think about any script, any Python, any macro. So most of the time, you can simply go check the code and immediately understand what's going on. Now, in case that the code is very large, in case that there is any obfuscation, in case that, I don't know, the names of the functions and the variables are randomly changed and it's calling like in this never-ending loop of functions and everything, then you can maybe spend a few hours trying to understand this. But LLMs are excellent at this, so they are saving you all the time, all the effort. So we applied this for scripts with very good results. And the next logical step was to see how we can do the same approach for executables, right? In the case of scripts, actually, we learn different things. The first thing is that AVs and LLMs do not necessarily agree all the time. And the reason for this is because there are some gray areas. If you are like an antivirus, you need to raise the flag if something is obviously malicious, and if something is doing some activity in your computer that is against what you expect for legitimate software, right? In the case of LLMs, this can be a bit more flexible. And actually, when you are prompting, you can specify your nuances. Let me put an example. Imagine that you have some script. This is a keylogger, but this keylogger needs one parameter in order to exfiltrate the data from your computer. So maybe the AV is like, well, yes, this is a keylogger, but it's not exfiltrating the data. What should I do? Most of the cases, being a keylogger should be like malicious, right? But in some cases, it will hesitate and maybe suspicious, maybe not. An LLM is way more explicit. So it will tell you everything about this code. It will tell you, well, we found this is a keylogger, this is missing this, and from here, it's up to you to consider if this is malicious or not. So all these nuances are very rich, and I think this is a very good addition to the most traditional security software, because you have from one side like the very specific malicious or not. And by the way, in 20 years, this has been historically our main use case. People is just interested, is this malicious or not? All the other signals that we are providing, in many cases, they are ignored. So by having this LLM, it's like giving you all these nuances, giving you all these different opinion around this. It's not just malicious or not. And actually, it shows like these capabilities that we discuss in order to understand what is the behavior. It provides some deobfuscation capabilities out of the box, et cetera, et cetera. And we also found some interesting stuff, like finding the different file types. This is not trivial. Most of the time, if you are analyzing any file, you will check the magic bytes in order for understanding what is the file type. So this is a P executable, for instance. But in some other cases, in terms of if you're analyzing a text file, you know this is a text file, but okay, what type of text file? Is some PHP code? Is just pure text? Is that some script? In this case, LLMs are excellent also in providing you with this information, which greatly helps. So we discovered all these capabilities as we were playing with LLMs. Now, the next step is, can we do the same for executable, Windows executables? Can we do the same for malware? And actually, this is one of the most difficult things. Probably some of you are reversers, or you are doing malware analysis, and sometimes it takes a very long time to understand what the malware is doing. It takes like a lot of expertise, many tools, etc. So this is the challenge, right? We did several approaches, and actually I will be showing you during this presentation the different steps we were following. But the first approach was very straightforward. The first step was using what we call, in this case, a backscatter. This is one module from Mandiant. And this module is helping us to unpack. There are some universal unpackers, not really, but there are many unpackers. In this case, if we happen to know this malware family, we have different signatures so we can unpack the malware and we can extract the configuration. So this is a very specific tool that we are taking advantage. Why? Because the biggest problem that we will find, and we already knew, and probably you are thinking about this, is things like pack malware, obfuscation, encryption, where you cannot truly analyze. So the second step was, once that we have this unpack malware, we will run it through IDA Pro. Probably all of you, if you are into malware analysis, this is the tool of choice. And we will decompile the malware, and in some cases, we will disassemble it instead. So once that you have the malware decompiled, we will throw it to the LLM. And this is something that until last year, we couldn't do, simply because we couldn't throw, we didn't have the capability of use so many tokens in one single prompt to share with the LLM. This has been evolving very rapidly. At the time, we were using Gemini 1.5, which is the first one that allowed like for 1 million, I think, 1.5, something like that. So in that case, we were allowed to provide with this full disassembly or the compiled code. This has been changing, as I said. It's very difficult to talk about LLMs these days because every week there is something new, but you get the idea. Once we have big enough window, we can throw the whole code. And actually, this worked pretty well under certain conditions. And the rest of my presentation will be discussing about these conditions, and it will be discussing about the things that work, and maybe more importantly, the things that didn't work. In this case, you can see, if you are not very familiar with VirusTotal, but you can see in the top left corner, this circle with 0 detections. It means that none of our antiviruses is detecting this as malicious, but when you see the code inside analysis, it does. It understands this is a keylogger, and this is one of the cases that I think is in this gray area where the antivirus is not going to tell you this is malicious because it's connecting to this 192.168 IP. But, well, it's for you to probably decide. So it worked pretty well. And actually, it was doing this deobfuscation like XOR and things like that automatically, which is great. Great capabilities out of the box. Now, sorry, wrong button. One of the things to keep in mind is you are going to use this against a collection of 50 billion samples. So how are you going to do it? For coding size, we were having some similarity checks before throwing new code into the LLM. And here we wanted to follow something in the same direction. Actually, in our tests, we were doing around 13 seconds average analysis time. Actually, this improved with the new models. It's something that we are, it's reasonable. Because when we're analyzing some code and we throw it into the whole pipeline, into the whole AVs, into the whole sandboxes, it takes more than this. So it's not adding up much time. We are reasonably happy with this time. The second thing is about having the right size for the prompt. As I was saying before, this is something that we were very limited in the past. And now we feel that most of the malware can be analyzed this way. Obviously, if the malware is 600 megabytes, it's impossible. But for something reasonable, under 1 megabyte, under 5 megabytes even, which is most of the malware, like 99%, this works pretty well. I will also discuss with you some other details, when to use disassembly or when to use the compile code. Most of the time it's the compile. In some cases, disassembly work better. Actually, we can add additional stuff. And when you have the malware, it's not only the disassembled code or the compiled code. You can also check what is the behavior in the sandbox, for instance, and add the same into the prompt. So we could add additional context, and this additional context obviously improve the answer. So once you are working with the LLM, keep in mind it's very flexible. You're analyzing the malware, but you don't need to limit yourself to the code. You have the code, but you have more stuff. In some cases, this is biasing the answer from the LLM, so we need to be very careful. I will tell you more about this. And as I said, this packers and obfuscation is the big deal for us. We were lucky to have a backscatter, but backscatter doesn't learn from every single malware family, so it's hard to have a universal solution. In some cases, you can think of, all right, let me throw this into the sandbox, and let me rebuild the malware from the memory, which is doable, but also it's not universal. It doesn't work well in all cases. Our approach was more like, let's build some kind of decision tree with everything we know that works, that doesn't. In this case, we will throw it through these tools. We will build the prompt in this direction. In this way, we will do differently. It's not the best approach nowadays. I will tell you later what we are doing now. But that was our initial idea. At the time, it was probably working quite well. And then different programming languages. In some cases, you can think of them like packers. So something in .NET, this is an interpreted language, so it has its own engine when it's running. This kind of stuff is not universally decompiled, so you need to use different stuff than IDA, for instance, and you need to use more specialized tooling. Hence, the approach with the decision tree that we were discussing 1 second ago. All right. With all of this said, let me show you some examples of how it worked for different malware families. And actually, our approach was very simplistic. We wanted to know from a very naked perspective how the LLM could handle different samples from different popular malware families without providing much more than the disassembled or the compiled code itself. Then we will see how this can be improved. But this is just the initial approach, and we were curious, like, what is the LLM able to do from scratch? So one of the families we started analyzing was Quackbot, very, very familiar, probably for all of you. In this case, it detected almost all the samples properly. What is interesting is that when you see the output from the LLM, it's slightly different from all the different samples. The reason is that not all the samples, or let's say there are different flavors for the same family. Not all the samples are exactly the same. So sometimes the LLM is like putting more focus in one capability than the other. It's not like an universal answer all the time. And this is interesting. I think this is biased by the sample itself, like what the LLM has the ability to see versus what is like more obfuscated or not. But in some other cases, I don't really know why. It's like focusing in one thing and not in the other. In the case of ngRAT, let me see if, no. Okay, so let me see if this works. Well, it works very poorly, but I want to highlight for you this part here, if you can see maybe. So in this case, for ngRAT, it was working very well. Everything was detected as malicious. We got, in this case, we were using assembly instead of the compiled code because it's written in .NET. And with IDA, well, it's not ideal. We need to use something more specific. But look at this. When we are asking, like, hey, can you provide us with some IOCs? In some cases, it's providing this, which is registry entry. If you read from right to left, you can see, right? Or here, you can see this is an invalid URL by all means. So in both cases, it's not giving us exactly what we are looking for, but this has an easy solution. Actually, we tried to find solutions as we found the problems, and this was our approach. In the case of Quackbot, we tried to provide some consistency with the answers, and the way we thought we could do that was asking for capabilities. It's similar to TTPs. If you're familiar with the Kappa tool, basically Kappa is telling you the capabilities of malware. It's using some different rules to find the capabilities during execution. And in this case, it's telling you the list. And we thought this could be a very nice output, so we could automatically compare all the output from all the different samples. It didn't work, unfortunately. In the case of improving IOCs, what we thought is that, well, every time you get an IOC, you could simply check if this IOC is valid. And there are different ways to do that. One of them is like checking if the IOC exists in VirusTotal, for instance, and retrieve information about this IOC. This is what at the time were called function calls. What they are still called function calls. So the LLM has the ability to make this call. This is what today we are all talking about agents, right? These are NCPs, these are agents. They are able to make the call to another server. In this server, the LLM will help you provide the information that you are missing. So the same concept that now is very popular, by now I mean in the last, I don't know, month or so, this is something we were exploring, but in this case with this function call. So our approach now is different. All the different items that we are discussing, this could be actually be replaced by agents, and we will go back to this later in the presentation. So we were having the intuition by creating these different workflows and these function calls and everything, but you can do this in a much more universal way with agents. This is Mirai. Mirai is a very well-known family, and in this case, this is one example of like the perfect solution. I don't know if you can see because it's kind of small, but I highlighted here. It's telling you all the different commands that it has available. So if you're analyzing a Mirai sample, you will find the whole solution in 13 seconds, less actually. And that's all that it takes for you to have a full understanding of this malware. By the way, we didn't find many hallucinations. It's not one of the problems that we found in this whole analysis. Actually, it didn't work well for everything. And this is one example. I just want to be open and share for the community everything we learn. In this case, is one interesting sample of Mirai. It was shared with us by the Fleur team. We compiled this with GHydra or Gydra. I never know how to pronounce this, I'm sorry. And it was doing something very interesting. One part of the code was identified by the LLM like, yeah, here is doing some networking stuff. And actually it was creating a socket. And the reason it was creating the socket is to check if the malware had root permissions. So it had nothing to do with connectivity. And this was misinterpreted by the LLM. So it's one of these tricks that the malware is using for something different, and the LLM didn't know. So we believe that all of these will be simply get better if we have more and more samples and the LLM keeps learning from them. I wanted to share, I found this very interesting. Anyways, it was a big time saver. Even if you don't have like absolutely everything, it found like the code for random number generation. So it's giving you many keys. In terms of the compile versus disassemble, usually the compile seems to be always the better choice, just because it's a higher level representation. So you can expect that the LLM is understanding better. Once again, in some cases, disassemble works better, but we couldn't find exactly all the cases. I don't think nobody knows, but it was when we saw very obviously that the code was using some techniques in order to avoid the analysis. So using disassemble worked better than the compiling. But it's very circumstantial. I don't think there is any real advantage in using disassemble as of today. Maybe that changes. So I think after analyzing some stuff, that there is like this whole spectrum, right? When you can find that it's doing all the job for you, it's analyzing absolutely everything, giving you the commands, the IOCs are checked, and everything. In some cases, it's actually not able to understand anything just because it's heavily obfuscated, encrypted, etc. And it was not able to grab the code. In terms of obfuscation and encryption, well, obviously worse results than when nothing is there. Low hallucinations, as I said. And one thing that I find interesting is that it doesn't care about which human language we use. It cares about the programming language because that affects the tools that we are using, and that affects the quality of the compiled code, for instance. But you can see here in this code, it was the first is some Cyrillic, the second, I'm sorry, I don't know. I will guess is, I don't know, Chinese. But the LLM doesn't care, and this is a huge advantage. It's just seeing like, the functions and understanding what they do, and not like affected by the language. And keep in mind that this was a technique used in the past by many malware developers in order to provide like false flags or to make more difficult the code analysis. You remember the Marvel framework, for instance, was doing that? So, all right. I told you before about enriching the context. Basically, there are different techniques that you can use here, in addition to share the code with the LLM. For instance, one of the best improvements we saw immediately was sharing the output of the sandbox. So the sandbox produces this HTML output. You just throw it along with the code, and this is helping the LLM to provide better results. It doesn't work well when you are including previous analysis in the prompt, because this is biasing the analysis of the LLM for the new malware too much. So there is this danger of biasing the analysis if you are putting I wouldn't say context, but you need to be very careful how you are prompting things. Otherwise, it will assume that this is true. So there is a balance here, and this is something that we should be very careful with. Including these function calls, as I said, is a big win. Now this is being replaced, all of this, with agents. And in the case of having this detailed output, this is also that we are getting better now. Why? Because of agents. So before it was trying to have this kappa output from the LLM. It didn't work well. Now we simply collect everything with these agents from different tasks, and then we have a dedicated agent to build the output. And this provides this consistency we didn't have before. So this was our path, but nowadays we have happily a better way to do things. Here you can see an example where I was telling you about the sandbox. Here we threw the code plus the sandbox, and the LLM is actually telling you, like, the sandbox report doesn't capture all behaviors observed in the compilation analysis, which is great. So it understands that this is not the unique source of truth. Like, I have all this data, let me work with all of this, and I can understand the difference, and I can tell you that some of the stuff, it was not detonated in the sandbox because it has some anti-analysis capabilities. So this kind of stuff you will never get from any other type of tool, I would say, because it depends on the detonation itself. So this capability of analyzing and comparing results is a great progress. Here, actually, I wanted also to show you this spectrum of very good and bad results that we had. We were working, again, with FLIR in analyzing different samples that they were working for some incident response. And you can see, like, something that is basically what we've been discussing during this whole presentation. A scripting language, like JavaScript, Visual, what is this? Is ANSYS script, PowerShell even, it worked very well. But when you go for something like way more complicated, then that depends. In this case, it failed, probably because we didn't rebuild properly automatically the analysis. And this is a problem in the sense that when you want to build something that is universal, it's complicated. You cannot, like, tackle all the cases, especially at the time we were doing all of this. Now we are more hopeful with the agentic approach because this provides way more flexibility, and we can use many other different techniques. And actually, before jumping into more details about the agentic approach, let me just tell you that there is another human approach, which is way more interactive. And actually, maybe you cannot see much, but if you're familiar with IDA, this is one plugin that we developed for IDA Pro, the VirusTotal plugin. And basically, this is telling you, you can select any function, and you can throw it to the LLM. The LLM will tell you what it thinks about the compiled code, and you can actually interact with it. So you can ask questions about this. You can provide your own vision, which will be improving the knowledge of this type of function in the future. And we thought that this is also an interesting approach. It's more oriented as a tool to help researchers, but it's basically the same idea. It's going through against the same endpoint, and it's giving you another possibility to work and to improve your analysis capabilities. Okay, so with everything we said, I would say that, once again, it's very hard to find this universal solution, but in my opinion, this is the way to go. And it's just getting smarter agents in what we initially called this decision tree that now we call a workflow. And this workflow basically is the different agents that we will be using for different tasks. And this is where I see we are getting better results. Because from this foundation that we started exploring, we have the potential, and we have many different use cases, many different good results. But it's very hard to throw something like this into production when you call it universal. This is the problem. But it will, at the current state, it will already solve the task for many, many people. Let me show you how it looks like what we are working on now. I think this is a very complicated slide, just to let you know that we are using agents. Basically, we are dividing the task in different stages. In every different stage, we are using different agents, different workflows. The agents are more autonomous, and the agents have the capability to interact with other systems, not only with VirusTotal, Google Threat Intelligence. You can also interact with, I don't know, SecOps. So imagine you find this registry entry as one of the IOCs. So you can have one agent just to check if this exists, what is the prevalence. But you can also check in an external system, like to SecOps, how many times you've seen this in your CM for the last 48 hours related to something suspicious. So even if you don't know this IOC as of today, you already have some context, additional context around this, which will help you in your analysis. And this agentic approach is what eventually we believe will give us the full flexibility that we are lacking with the previous approach that is based on a flow and is based on a bunch of tools. So with this flexibility, we were experimenting, even if it is not very visible. Here is, we implemented a full prototype with the full framework, the whole agents and everything, analyzing some code. So in the first stage is triaging, and it's like, okay, let me see what you have here. This is this type of file. This type of file has these different capabilities. This is what I see. The second one here was extracting the code. What is interesting is that it identified automatically, oh, there is some base64 stuff. Let me extract this for you. And the code was automatically generated. What is better is that this code finds an error. And the error is caused because of the headers that the attackers are playing with. So you cannot extract this with an automatic library. So automatically it's patching the code. It's like, oh, well, this code is not working. Let me fix this. And it finds the hack to solve this problem with the code. And as the last step, it identifies that in the output, the attackers are inserting all these null bytes, and all these null bytes are just created to put more noise and everything. So basically, it's able to create the code to also clean up this output. So basically, the agent is creating this code dynamically because it understands what is analyzing. From the output, understands if something is broken, is fixing this itself, and is giving you the final answer. Will this work with absolutely every single sample? Absolutely not. But this approach looks way better than what we were discussing before, because now we have this flexibility. And what is better? We can keep adding agents. And all these agents will have a capability to specialize in different tasks, and they can be better. We can use these MCP servers to connect to other systems and provide additional context or additional capabilities that maybe we didn't implement ourselves. So I'm very happy about this, or I'm very excited about these new capabilities, because I think this is the piece of the puzzle that we were missing. Okay, and still I think I have a few minutes, yes? Okay. I just wanted to quickly go into the bonus part of my presentation, because I've been talking about this topic for the last couple of years, and since the first day, I'm not sure about that today, but since the first day, everybody was asking me, hey, are attackers using AI anyhow, or have you detected any malware created with AI? And I always decided to add this part into my presentations to answer what I know today about this. So if you don't mind, I will do that just in a couple of minutes. because I feel like this is more boring today than it was exciting in the past. So the main capability that we see attackers using, you guess, is deepfakes, is fraud of all type, is creating content. And as I always say, you will use, if you're an attacker or not, you will use any single tool that you have to make your life easier. And this is basically what attackers are doing as far as we know. So in the past 2 years, everybody was looking like, oh, let's try to fish anything that looks like AI generated. Nobody succeeded because it's impossible to know if something was AI generated or not, unless you find something very specific like the prompt inside, which some researchers were using. But in terms of creating anything fake, visually, audio, video, and helping in any kind of a scam, well, you see that every day, right? You see all these bots everywhere. In some cases like this, they are open to prompt injection. Actually, there are a couple of papers I would recommend reading. All of them were published at the beginning of the year. There is one from OpenAI. There is another one from Google Threat Intelligence. And basically, it's dissecting how different attackers were seen abusing, in this case, Gemini. TLDR, basically they are doing what you will expect them to do, which is try to go faster, create some scripts, do this reconnaissance for me, and help me write some code. In some cases, in one of the cases, in this, how is it called? This forest resort, I'm not familiar with this APT. It was researching some kind of exploit or vulnerability. So once again, it's what you will expect to happen. All right, so bonus is over, and actually my time too. I hope that was interesting for you, and we have time for some questions. I'm happy to answer if you have any. Thank you. So there's one question there. Feel free to use the mic. Yeah, there are some mics. I don't know who is. Oh.
Hi, so my question is, what kind of challenges have you encountered discovering hallucinations when malware analysis is taking place? Because I would imagine you might have to do the analysis yourself to know whether it's wrong, right?
Yeah, you're right. So we started doing this very manually. Then when we detected some patterns, we were looking for these patterns, like, oh, let's check if this malware family is saying this or that. I think that most of the problems were basically with the IOCs, most of the visible ones. In some cases, it's true. It was saying like it's able to do this or that capability, and this was based on nothing that we know or we could see. We found some explanations, like in this case, checking to create the socket, like, oh, okay, this is this trick to see if you are root or not. But in some other cases, we don't really know. Having said that, I don't know what to tell you because the models are changing so quickly that it's for me very hard. And this data actually, we didn't rerun because, well, in order to prepare a presentation, you need some buffer time with the latest models. And I'm very curious to rerun this and see how this evolves or not. But my impression and our data doesn't show like, oh, this is really terrible because it's hallucinating all the time. Most of the time it's doing well. It's difficult for me to put a number, but I will say we are happy with the results. It's not something critical. But yeah, you're right that it's hard to check this.
Thank you.
Thank you.
Yeah, I got a question. So, and this comes from an angle from somebody who does something else. We do binary vulnerability analysis, but we find that the disassemble and decompile aren't 100%, and everything going, they have some inaccuracies compared to the original binary, and that seems to often cause problems, at least with the stuff that we do. And I was wondering, is this something you see with the malware analysis too, where the decompile essentially doesn't really reflect 100% the original behavior, and then everything that you explained that builds on top of it is essentially a house of cards, for those instances where the disassemble or decompile is already not really 100%, or I don't know if you've seen any of that.
Yeah, well, thank you. It's very interesting what you said. You're right in the sense that we have a binary and we are trying to find a representation that the LLM will be able to work with. In some cases, this will be not a feasible approach because the whole binary is built in a way that the tool will not disassemble or decompile correctly. And we have seen this in the past. There are several examples of some APTs where it really needed some magic in order to provide with the real code. So for such cases, we don't know how far we will go in terms of agents being able to figure out all of this. Still, it's very early to say. We are not trying to fix this problem, to be honest, in the sense that, and you're right, I get your point, like, oh, this is built on House of Cards because the first interpretation is not proper. We are trying to put as many signals as possible, as I said, like behavior and whatsoever. But we are not trying to find all the corner cases. It's more an approach that we are trying to help regular analysts who are analyzing per day, I don't know, 200 samples, and they need to have a quick understanding what's going on. You will always need super specialists to do the proper job and to analyze things properly. Maybe we'll make life easier because we will identify key functions, and from here you don't need to bother, and you can focus on the tricky ones. So it's not an universal approach, and you're right, we are limited to our own tools. Maybe someday we will have more tools that will help these agents understand, well, you are wrong here, you need to do more magic in order to decompile this the right way.
Thank you.
No
That
problem.
makes sense. Yeah, I'm hoping that it's going to be LLMs helping with producing the better decompile, right? But that's going to be way out, I think. I don't know, what's your thought on this? Sorry, just asking follow-up.
LLMs creating sorry?
Yeah, like the fixing the decompile.
Oh.
I
Eventually, maybe, I don't know. This is not something we have tried, so
Yeah.
I don't want to,
We haven't-
wildly speculate like LLMs are able to do everything properly.
Yeah, and we haven't either, so I just throw it at you as an idea.
Oh no, it's fine, it's fine. I just, brainstorming with you. Maybe yes, but honestly, who knows, huh?
Thank you.
No problem.
So I have a question. Do you see in the future, let's say, a way for it to give us binary results such as undetermined, malicious, benign, or is that something that isn't doable currently?
Yes, I see this because everybody wants rapid triage, and everybody wants like bad or good. And actually, this is something that we include in our prompting in the output. Like, first thing you see is if this is malicious or not malicious. Now, if you ask me about my very personal opinion, I think this is a very simplistic approach, but I understand that you need to find the balance with this rapid triage, especially if you are connecting this to a CM or something like this where you're analyzing hundreds of thousands of events per hour and you don't want to spend more time. We provide more signals. We're always hoping that our customers are using that in their playbooks. Like, well, other than this, please let me know if you have seen this with some threat actor, some recent activity, whatsoever. But yeah, most of the cases, users are happy with malicious, not malicious. I still think that LLM can do better. And I still think that eventually you could adjust the LLM behavior to your own security posture, finding this magical balance where you are extremely happy with what you get because your team is what it considers that this needs to be further analyzed, and it's not we or whoever telling you. So LLM provides you with this capability, and I think here is where the most potential you will find in the future in order to adjust all this tooling to your own needs.
Thank you.
Okay.
Hi, I have a question regarding, have you tested vector stores or vector databases for storing the disassembly or the decompiled source? Because that would give you basically more storage instead of shuffling it into the actual LLM context window, and how that would compare with the context window method, because then you would be able to put potentially both the decompiled and the disassembly into the vector store, so the LLM will be able to access both at the same time.
Yes, we didn't. And the answer why we didn't is because at the moment we are not reaching this level of granularity. If I will design a solution that I will go deeper and I will want to not only identify the malware and the output of the LLM, but to really like break it down so I can check every single dependency, every single function, and go into this deeper level of understanding, then obviously yes. But I think this is a different approach, where you want something more like to the genes of the malware, let's say, and find this capability to identify them uniquely regardless of the sample itself. So you can identify different parts, functions, relate this to even some threat activity. It's going a bit deeper, and this is not what we do ourselves in the sense of what we want in our product. But it's a very cool approach, and I think it's very interesting.
Yeah, and then you can also pull in potentially external DLLs and disassemble them and put them in the vector storage. You would get dependencies and everything as well, so you can have like a full
Yeah.
system.
We're thinking to build this with this IDA database. How is it called? Maybe you know, guys. There is this IDA capability database to store all this information about libraries and everything. I just forgot the name, I'm sorry. But to leverage this, not to build from scratch. I don't know, because I don't see, maybe you work for Intesa or something like that, but these guys, I think they do something like that. They go deeper and they analyze at a deeper level.
Thank you.
I just wanted to know how different LLMs react, or how do they improve the quality. So do coding specific model are better at this, or general purpose models or thinking models are better at this? What's been the outcome?
So inside of Google, there are different approaches. And I will tell you what is our approach. Our approach is twofold. From one side, we are open to include external LLMs dedicated to malware analysis, because Various Total Spirit is an ecosystem. We aggregated all this data from AVs and different tools, and also we aggregate different LLMs. So if you check as of today for coding sites, we have different providers. Now, in our experiments, we're using basically different Gemini models. In order to make these improvements, we are more in a RAG approach rather than developing a full new model. Now, there are teams inside of Google that they are doing that. We didn't really do this benchmarking and finding like the different capabilities for the different approaches. But eventually we will be able to do so. When we do so, well, we will see which is better for different circumstances. And probably with the agentic approach, you could use both, or you could use different models and see which one works better under different circumstances. I don't know how specific this is. I don't know how specific this is, because our approach is more like, if you know how to code, I kind of expect you know how to analyze. But maybe with all the discussion we are having today, there's different nuances that we will need something maybe more specific, which I don't know if it is a tool or an LLM by itself. It really depends on the different capabilities we want to leverage.
Thank you.
Thank you. All right. So if we don't have more questions, I really appreciate all of you attending today. I hope that was interesting once again. If you have any doubts or you want to ping me, very happy to help you. Thank you.